Soil is a vital part of our society as a whole. It supports life and biodiversity, stores important nutrients, holds groundwater reserves, supports buildings, and detoxifies ecosystems. Unfortunately, the Earth's topsoil is rapidly decreasing due to erosion and other causes. Half of the topsoil on the planet has been lost in the last 150 years. The effects of soil degradation go beyond affecting the environment and also deeply affect the world's economy and society. While there are many challenges to maintaining healthy soil, luckily, there's also several viable solutions to resolve this issue.
Soil degradation is the decline in quantity and quality of soil, including erosion by wind and water, biological degradation, physical degradation, and chemical degradation. Water and wind erosion account for 80% of the 20 million kilometers squared of degraded soil worldwide. Causes of land degradation include the reduction of the natural vegetative cover, which renders the topsoil more susceptible to erosion, as when huge areas of forest are cleared for logging, fuel wood, farming, or other human uses. Unsustainable land use practices such as excessive irrigation, inappropriate use of fertilizers and pesticides, and overgrazing by livestock, groundwater over-abstraction, and atmospheric deposition of heavy metals and persistent organic pollutants, making soil less able to sustain the original land cover and land use.
The environmental effects of soil degradation include the loss of arable land, clogged and polluted waterways, increased flooding, and desertification. Soil degradation can lead to the loss of topsoil and the destruction of soil characteristics that make agriculture possible. This also leads to a reduction of seed germination of native plants. Another environmental effect of soil degradation is clogged and polluted waterways. Soil eroded from the land with the effect of pesticides and fertilizers washes into streams and waterways and causes sedimentation and pollution that can damage freshwater and marine habitats and the local communities that depend on them. This also leads to a decrease of water infiltration and groundwater recharge. Increased flooding causes increased surface runoff and stream discharge. A final effect of soil degradation is desertification. Desertification leads to a loss of biodiversity and development, and also leads to the increase of erosional gullies and sand dunes.
The socioeconomic impacts of soil degradation include a lack of farming productivity, unemployment, migration, hunger, and malnutrition. Soil degradation causes the quality of soil to diminish, thus resulting in a lack of farm productivity. This lack of farm productivity leads to a decrease in crop production, which leads to an increase in rural unemployment. Soil degradation impacts poverty-stricken areas the most, especially in Africa and Asia, since these people have occupations mainly in the agricultural sector. This leads to people being unable to obtain necessities for everyday life, leading to an increase in hunger and malnutrition. To escape this, people also feel the need to flee the rural area and migrate to urban areas, which can potentially lead to overpopulation.
There are many viable solutions and management strategies, including practicing sustainable agriculture. This restores and preserves critical habitats and improves health and quality of the soil. Another strategy is decreasing deforestation through sustainable forest management and reforestation, as well as preventing desert expansion. There are also mechanical solutions like embankments, bunding, terracing, contour plowing, and shelter belts. Legal action is also helpful, like the European Union Soil Charter in 1990. In 1990, European Union ministers met to discuss the problems of soil pollution. Over 30% of European soils were considered to be moderately or severely damaged. As a result, they drew up the Soil Charter. Its main points are: soil is one of the world's most important resources. Soil is a non-renewable resource that is easily destroyed. Farmers must use methods to preserve soil quality. Soil needs to be protected against erosion and pollution. Urban development causes great damage to soil, and soil must be managed in a sustainable way. There is a universal soil loss equation that predicts the amount of erosion on the basis of certain factors that increase susceptibility to erosion. R, K, and LS stand for ecological conditions. R stands for the erosivity of soil, which is the rainfall totals, intensity, and seasonal distribution. K stands for the erodibility, which is the susceptibility of a soil to erosion. LS stands for length slope factor. The greater the slope, the greater the erosivity. The longer the slope, the more water is received on the surface. C and P stand for land use type. C stands for crop management, while P stands for soil conservation.